Hi everyone, it's Mrs. Curl, and today I want to talk to you about first differences. We're going to begin with the relation of y equals 2x plus 1. We want to be able to complete the table of values and to graph the relation. So let's begin with the table of values. Remember, we're using the equation of y equals 2x plus 1. And so in order to complete this table of values, what we want to do is sub in each of those values in for x to see what our y value would be. So for example, for 0, if I have 2, so let me just grab my pen here. If I have 2 and then times 0 plus 1, that would give me 2 times 0, which is 0. 0 plus 1, which is 1. So my y value would be 1. If I plug in a 1, I get 2 times 1 plus 1. 2 times 1 is 2, and 2 plus 1 is 3. And then 2 times 2 plus 1, which is 4. 2 times 2 is 4, plus 1, which is 5. And we should see a pattern that's happening now. But I'll keep going. 2 times 3 plus 1 is 6 plus 1, which is 7. And 2 times 4 plus 1, which is going to be 8 plus 1, which is 9. Okay. Once we have our numbers, put them in, try to put them in a little bit neater for you to see. So 1, 3, 5, 7, 9. Now from here we want to graph the relation. So that means going to each one of those points. So 0, 1 will be my first one, which is right here. And then 1, 3, which is up here. 2, 5, which is here. 3, 7, which is up here, and then 4, 9 is here. And if we've done our table of values of right, what we should notice is that we end up the nice straight line that goes through all of our points. Oops, let me just undo that for a second. There we go. Let me put in that straight line again. Oh, I don't know why it keeps doing that. But anyways, here we go. So we have this nice straight line that goes through all of our points. And that shows us that we have a linear relation, which is what we expected anyways. Of course, because looking at this function, y equals 2x plus 1, we could see right away, since it's degree 1, that we were expecting to get a straight line. Okay. So when I talk about first differences are a way for us to examine a table of values to see if we have a linear relation. Okay, and in order for it to be a linear relation, a couple of things have to happen with our table of values. First off, we need to make sure that our x values, so these are these values here, are all going up by the same amount. Okay, so they have to increase or decrease by the exact same amount. We can't skip numbers. And secondly, we have to make sure that they are in order from least to greatest. So looking at my x values here, I have 0, 1, 2, 3, and 4. They are in order. They're all going up by 1, which means we're good to go for our first differences. First differences actually involve our y values. So we're going to look over at our y column. We're going to begin at the very bottom of our y column. So we can just go to the bottom here. And notice I'm going to put just kind of a couple of lines there. What we're going to do is we're going to start with our very bottom number, which is -9. Sorry about that. My pen is not writing well today. And we are going to subtract the number above it. So -9 minus 5 minus a -5. So remember, 2 negatives make a positive. So 2 negatives here make a positive. So -9 plus 5, which is going to give me -4. All right, let's continue on. And I'm going to go now to the number just above that. So -5 and subtract the number above, which is a -1. So remember, again, when you have two negatives, it means positive. So really what I have is -5 plus 1, which is -4. And then again, I'm going to go now from the -1 and the 3. So -1 minus, now this time it's a +3. So -1 minus 3. Notice there's only one negative sign, which is going to give me -4. And then last, I have 3 subtract 7, and I end up with 3 minus 7, which is -4. Okay, and since we have the same number every single time, that means that we can say that this is linear. Okay, so that's what our first differences can tell us, is that it's linear if we end up with the same number every single time. So let's go to another example. Okay, here we have this example. So the first thing we're going to do is we're going to check our x's. Are they increasing or decreasing by the same amount is the first question you want to ask yourself. And I can see here it goes 0, 2, 4, 6, and 8. So they're going up by 2s, which is good. And are they in order from least to greatest? And they are. So we can examine our y values then. So let's take a look at these y values and figure out if we have a linear relation. So I'm going to start by subtracting 17. So notice I start at the very bottom and I subtract the one above it. So 17 minus 9. And 17 minus 9 is 8. And then I'm going to go to the one above that. So 9 minus 3. And 9 minus 3 is 6. Oh dear, I'm already seeing a problem. And then I can keep going though with this, which is good. Let's keep going. I have 3 minus a -1. Two negatives, of course, mean positive. So that's going to be 4. And then -1 minus -3, which is the same thing as +3. So that's a 2. Okay. So obviously we ended up with 4 different numbers here. And 4 different numbers would tell me that if I graph this, I would not get a nice straight line. I would get something with a curve. And therefore, it's nonlinear. Now, just to be clear, if all those numbers had been, let's say, an 8, other than one number that ended up as something different, it's still nonlinear. The only time it can be linear is if every single number is the same. If it's even one off, it's nonlinear. Let's keep going. All right, here we go. So I'm taking a look. This one might be a little bit harder to see, but I'm going to check my x's first, checking to make sure they either increase or decrease by the same amount. So I go -4 to -1, +2, +5, +8. So they are increasing by 3 every single time. And they are in the order of least to greatest. So I am good to go on this first differences. So let's begin. I want to start at the very bottom and subtract my way up. So 10 minus 5, which is 5, and 5 minus 0, whoops, which is 5, and then 0 minus -5. 2 negatives, that means it's a positive. So 0 plus 5, which is 5. And then -5 minus a -10. Oh, we got that double negative again, which means -5 plus 10, which is 5. And we can see now we have all the same. We got 5s all around. So this is linear. Awesome. Okay. So here's an example of one that we're kind of missing something over in the x's. So I wanted you to see what that could look like. So here we have 0, 1, 2, but then notice I go 4, and then I go 7. Okay, so we're missing some pieces in between. So we can't do a first differences like we would normally do. So we can't just start at the bottom and subtract our way up because of these missing numbers that are there. So if I went ahead and tried to do something, tried to do my difference table, I go 24 minus 15, which is 9, and then 15 minus 9, which is 6. And I would stop there and say, oh no, this is not linear because I've already gotten two different answers. There we go. I've already gotten these two different answers. So I know that it's not linear based on this, but this is where first differences fails you. So if you're missing pieces, then we can see that it's going to come up as nonlinear. But if you actually went ahead and graphed this, so why don't we just take a minute and like plot these points on a graph. So let me pull up a grid for you. So let's say coordinate grid, and go to images. If you ever need like a graph, this is a great way of getting a graph. Just type in coordinate grid, and then from there it will allow you to see all the, and then you can just pick whichever one that you like. So I think I like this one. So I'm going to copy the image, and I'm going to go back to my Smart Notebook file, and I'm going to paste this on. Oops, it's a little big. That's okay. We can shrink it up. There we go. Okay, so I want to show you. So when we did first differences, we ended up with something that said it was not linear. But now, if I actually go ahead and I plot these points, so 0, 3, and oops, my grid isn't big enough. So I make this mistake all the time too, is I don't pull the right one. So let's go here and copy image. We pull this one instead. And paste. Cool, that's really big. Okay, so let's say I need to get all the way up to 24. On my x's, I can go up by 1, but on my y values, I'm going to go up by, let's say, by 3s. So that's 3, 6, 9, 12, 15, 18, 21, 24. Okay, so let's go up by 3. So 0, 3 would be this first one here. And then 1, 6 would be right there. And 2, 9 is right here. And then I jump, right? I go 4, 15. So 1, 2, 3, 1, 2, 3, 4. 15 is right here, and then 7, so 5, 6, 7 here, and 24. And I want you to take a look at these points, and what you should see is that these points actually are creating a straight line. So this is where our, sorry about that, I'm moving things all around here on us. This is where our line of best fit kind of fails. Oh dear, this is really moving things around. I apologize. But it's where our line of best fit actually fails us. If it is skipping, I'll do that. If it is skipping numbers and we're not able to see whether or not it's linear or not linear, we have to actually go ahead and graph it. So just make note of that if you notice some missing pieces in your X column, that your table of values is not going to, your first differences are not going to work for you. Okay, so just to conclude here, a couple of notes that you may want to copy down. All X values must increase or decrease by the same amount. Okay, we need to make sure that it's either going up by the same or down by the same. It has to be that pattern. Our X values need to be in the form of least to greatest. We want to make sure that when we're subtracting our y values, we subtract from the bottom up, and that'll become a little bit more important as we start pulling everything together. I know you can probably look at it from the top to the bottom, but trust me, you want to go bottom up. It's going to be important when it comes to tying this all in with our slope. And if the y values are all the same, then we can say that this function or this relationship is linear. And if even one y value is different, then of course our function is non-linear. So very important with our table of values that we can see the x values are going up or down by the same amount, that they're in least to greatest, and we're going to subtract from the bottom up. From there, if your numbers are all the same, it's linear, and if even one number is off, it's not linear or non-linear. Perfect. A little bit of homework for you guys to try, and I hope you don't have any problems, but if you do, remember, email your teachers. We're here to help you at any time. Thanks for watching.